Let's take a look at how to find the mean square error. If you already have the sum of square errors, it's a very easy calculation, but let me go ahead and go through from the actual data. So in this case, we have some high school GPAs, and then we have some actual college GPAs from those same students. And we have a regression line here, regression equation that tells us what our predicted GPAs would be for each of the students based on their high school GPA. So in each case, we're taking 1.99, that's the y-intercept, plus the slope of 0.3156 times their high school GPA, and that's giving us these predicted GPAs right here. The error then would be the actual GPA they got in college minus their predicted value. That's how we're getting these 6 errors. Squared errors would just be taking each of those 6 errors and multiplying them by themselves. And then the sum of squared errors is really a nice term because it tells you what it's doing. It's adding up all the squared errors. So here we're just taking the sum of these 6. Again, all of this we could do in a calculator also. And then the sum of squared errors is the square of the mean squared error. And in other words, we want the average squared error, and we do have to adjust it for degrees of freedom. That's why there's an n minus 2 on the bottom. So n stands for the number of data points here, the sample size, and there are 6 data points. 6 minus 2 gives us 4, which is why we take that sum of squared errors divided by 4. If there had been 20 students here, we would have divided that sum of squared errors by 18. So we're dividing by 2 fewer than the number of observations that we have here. So that does give us our mean squared error. And you can see that right here, 0.0988. Do notice that mine was 0.0987. And my guess is that they were rounding along the way. So this is a rounding error. This is very slight. If you ever run into that's extremely close, your answer and the correct answer, do let me know, and I'll see if I can change the tolerance, because this is certainly a correct answer here, and it's just a rounding issue.